Okay, so I'm going to look at the concept of sine theta and a way to remember what type of triangles and the ratio of the sides that can occur for some specific angles. For example, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And what do I mean? I mean, take a triangle like this, where opposite this angle there is a side which we call opposite to make life slightly easier for ourselves, and this large side here we call the hypotenuse. Now, the ratio between the opposite, the hypotenuse, and the angle in here, that angle, we can say for a right angle triangle is held together by this function sine theta, such that they are correct in their relationship to each other, so that there is a right angle triangle. So for theta at 0 degrees, 30 degrees, 45, 60 degrees, and 90 degrees, it is advantageous for you to know how the hypotenuse of that triangle, the largest side of the triangle, and the opposite of that triangle, the side opposite the angle, relate to each other. What is the relationship between these two for certain degrees? And these degrees I have chosen not just because they have advantages to knowing them for general geometry, 60 degrees, 45 degrees, relationships to squares, equilateral triangles, so on and so forth, but also because they tend to be the ones utilized in exam questions. So one way to remember what the ratio is between the opposite and hypotenuse for certain angles of a right angle triangle is to consider, first of all, just to aid in memory, this is the only reason that I will do it in this plan. I could do other numbers, but to aid in memory, I'm going to use 2. I'm going to multiply by 2, multiply by 1/2 all the way across. So divide by 2, divide by 2, divide by 2, divide by 2. And why I'm doing that is mainly just to aid in memorization, but it does have some other meaning which I can draw upon to aid in our understanding. And that is to say, this is me suggesting that there is a hypotenuse of length 2 for every one of the triangles that we're going to consider the ratio between the opposite and the hypotenuse. So what does that look like? That looks like this, where I've manifested this structure. There is a right angle triangle, and I've decided to make the length 2. 2 what? 2 God knows. But the idea is, if it were to be 1, I would instead put the length at this for this diagram. But I've doubled it, and I've decided that I'm going to do 2. Why? Because it aids in memorization for a little trick that I'm going to show you in a minute. So far, sine theta is a function that allows for us to discuss how the hypotenuse and opposite and theta need to relate to each other so that you get a perfect right angle triangle. There are some angles that I believe are worth remembering: 0, 30, 45, 60, and 90. And one way to remember them is to start the discussion with there being a hypotenuse of length 2.